I'm Costas Calamvokis. I've had a bit of an introduction, but so this is work that I currently work for this networking startup in Palo Alto in California. I remotely work for it. Before that, I did the work for Fishman on their Tripleplay system, which is a MIDI guitar system, and that was using JUCE. Before that, I worked on this, which was for plugins that I worked on myself. So before I get started, who here is familiar with audio plugins? Is it everybody? Everybody. And obviously C++. But Lua, is people familiar with? Yeah, a few people familiar with Lua. Okay, so don't have to explain too much. Before I dive in, some related work. There's quite a lot of scripting that's going on in the audio community. And the first one I was in contact with was Contact, the Native Instruments sampler, and they defined their own language. It's a homebrew language, and it does note processing and also provides you with a simple GUI. So if you look at one of their instruments, like their grand piano here, this bottom bit is implemented using their own scripting language, and that gives you control over a few of the sounds parameters. And there are a lot of other things that are using this scripting, but I'll just touch on one more, which is UVI's Mach 5 sampler. And this one is actually using Lua as well. And it's almost a fairly similar approach where we overlap. They've done things in a fairly similar way, although not quite the same. And this wasn't out when I started, so I didn't copy this, and they didn't copy me because I haven't told anybody about it. So. I won't go into any details of it, but it's very similar to this Contact approach. My motivation was slightly different from that. I wanted to be able to define the whole plugin in this scripting way in order to make it very fast to play around with the plugin, to develop new plugins, and cheap, because I'm interested in MIDI guitar. There aren't that many MIDI guitarists about, so you have to be able to develop these things quickly. And the other side of it is opening up development to less technical and maybe more musical people. And this is what's happened with Contact scripting, for instance. There's a whole little industry going on there where people who used to just develop sample libraries are now developing instruments with samples and some coding in there that makes it work in a particular way and adds value that they can sell. So it sounds like a number of people are familiar with Lua, but basically it's a scripting language which makes things quick to write. Scripting languages the emphasis is on making things easy rather than making them run quickly. And so it's easy to experiment when you're developing these things. But the problem is it can't really compete on runtime efficiency with writing a compiled language like C++. But this is actually changing as we speak, because the just-in-time compilers are getting better and better. And there is actually a project out there that is doing audio processing even in Lua. So, but in my system, what am I going to say? Oh, right. Yeah, well, I'm just going to explain a little bit about what parts are implemented in Lua and what in C++. So we've got a simple blocks that you might have in a synthesizer, the oscillator to generate the sound, the filter to manipulate the sound, and a VCA to control the amplitude of the note. So that's the simplest synth you could have, probably. So then you've got to define how those blocks are connected up. So the oscillator feeds into the filter, feeds into the VCA, and goes out to the outside world. There's some kind of note handling you need. When somebody presses a note on the keyboard, you have to work out what actually to do with the oscillator, because maybe they're playing two notes and you only want to play one of them. There's some priority and stuff in there. And there's also envelopes which control parameters within these audio processing blocks, so that the note starts, gets louder, goes quieter when you take your finger off the key. And finally, there's some kind of GUI, which allows the user to select a particular sound. So I've implemented these audio processing blocks in C++. So there's just C++ classes that implement the oscillator or the filter or the VCA. And then everything else, the definition of the connections, the note handling, the envelopes, the definition of the GUI, all of that is done with Lua. So a few words about Lua. This is their description: a powerful, fast, lightweight, embeddable scripting language on their website, and it's, I think, is a reasonable description. It is a powerful language. It's definitely fast. It's only 100K or something when you embed it into your code, and it runs by interpreting bytecode. So the script is first compiled to bytecode, and then it's run on a register-based virtual machine. It's been around for 20 years or so, so it's quite mature. There's a very nice book they've written, quite a thin book, which tells you all you need to know about it. And it's very widely used in games such as World of Warcraft, Angry Birds. It's used in Adobe's Photoshop Lightroom, and as I've said before, in the audio in Mac 5, and apparently at Rowley too.
Yeah, we don't use it actually in the
Right.
product.
Right, okay. So I'll quickly go over connecting Lua and C++. It's very simple. There's various different ways of doing it, but the way I've chosen is the easiest, the most basic way, which is called Luna. And you include this .h file in your code. It's only a few hundred lines of code. You can go and look at it if you want. But what that does is it hooks up the C++ class into the Lua namespace. So that'll let you do, I've got this simple object-oriented type example that I've stolen off the internet, where you've got a bank account and it's got a balance. And when you first set it up, you give it the initial balance. So what Luna will do is, in your application, when you call Luna account register, it'll put into the Lua namespace your account class with a method, a new method, and then you'll be able to just go account.new and you'll get an object of this type. And then you'll be able to call these methods on the account in Lua. So you'll be able to call the deposit, withdraw, balance method. And all of the communication is done using a stack. So it's very simple. So if you look at the deposit method, it gets passed in this thing called the Lua state, which is the whole state of your Lua program. And you call a function from Lua, check number, which just takes the first thing off the stack and returns you a number. And it can also throw an error, but won't get into that. And so this is just adding that to the balance. So you can see it's very easy to do this, and this is returning a value. It's you just push it onto the stack, and then back in Lua, the value is just the return value of the function that you've called. So, and it's very easy to write an application. I mean, this is the whole application, which will read a Lua file, and well, define this class, read a Lua file, and you can then be using the class straight away. The way I've done things, I didn't want the users to actually have access to the scripts mostly. So what I do is I take the script and run the Lua byte compiler on it. So I end up with a byte compiled version of the script. And then I can just embed that straight in the plugin. And the interpreter then runs and reads the byte code directly. It can also, the interpreter is the same for the normal code and the byte code. So you can still, using this same interpreter, have normal Lua used for your config files, for instance. You can still use that. But when you're developing the scripts, of course, you don't want to go through that process. You just want to be able to edit the script, reload the plugin, and have it run. So while I'm developing it, the bit of Lua that is embedded in the plugin is simply something that just reads the real Lua from a file outside the plugin. So that makes it very quick to turn around to play with things. For the architecture, I've gone for a really standard plug-in architecture. Is you have one thread that processes the audio and the MIDI, and you have, or more than one thread, and you have another thread that handles the GUI. And you could imagine a script that handled both of those, but I haven't done that. I've kept them completely separate. So there's a GUI script which you can define your controls with, and there's a plug-in script where you define all that connection and the envelopes and things. And this means that those two scripts are running in completely separate Lua interpreters. There's separate memory. There's no locking required at all. And they communicate as most audio plugins communicate through parameters between the GUI and the audio processing side. And that's a very good thing because there's no locking and you don't end up with glitches in the audio side while you're waiting for locks from the other side. So I won't go into this too much, but the GUI script has just got, you can define your control, you tell it which bitmap to use, you tell it where. So it's quite a low-level thing so that so the plugins are not going to look, they'll look however you want. There's no, they're not going to look like a particular thing because the controls are baked in. So yeah, that's just a control, and it's got an enumerated type, this particular control, which you can do just by telling it what values to have. And this one's an integer, and you can have a floating point control, whatever. And you can define callbacks for your control, so when the control's moved, it'll call that function, and that function just makes sure that the min never goes above the max, in this case when you turn the knob. So on the plugin side, you implement functions like on note, which is run when a note is pressed on a keyboard or whatever, or on pitch wheel, which is run when a pitch bend command comes across MIDI, or on controller, which is a MIDI controller. Don't really use note off, but I'll explain that in a minute. And then if you were implementing a synth, that would be it, because you'd take the notes and then you'd work to control the oscillators to produce the sound. But you could also be defining a MIDI filter. So you could be taking in MIDI, doing some processing on it, and then sending it out to somebody else's synth, in which case you'd be calling these send notes and send controller things to send MIDI out of the plugin. I'm going to explain a bit about how the on-note function works, but before that I have to explain Lua coroutines. So in Lua there's this idea of a coroutine, which is, it's similar to a thread. So it's a line of execution, it's got its own stack, it's got its own user variables, it's got its own instruction pointer. It can still access the global Lua variables, but there's a bunch of stuff that are its own. And it's unlike a thread in that there's only ever one thing running at a time in a Lua interpreter. So they're not going to be treading on each other. And it only gets suspended when it actually asks to be suspended. So it has to call a function to say hand over, and then something else will get run. So you end up having Lua that says run this coroutine, the coroutine runs, and then it hands back control to the place that told it to run it. So the on-note command function is actually run as a coroutine. And the reason that it's a powerful thing, because all of these variables, for instance, are local variables. So if you look at what's happening here, this is simply transposing a note by whatever value's been set by some knob. So it just takes the note, it adds whatever 5 semitones onto it, sends it out. And then the coroutine goes to sleep. And this sleep function here is saying sleep until note off, which is when the person takes their finger off the key. And at that point, you can then send the note off on, and you send this same note in the same channel. And it's a bit hard to tell from this example, but that is a very useful thing to be able to do, because all of this thing is local. If somebody changed that transpose value between the note going on and the note going off, it doesn't matter, because that value is local, and you're going to get the note that sent, the note off is going to match the note on, which is vital in MIDI, because otherwise you get stuck notes. So you don't end up using this on note off callback usually. This is a slightly more complicated example. You can sleep for a time as well. So in this case, if the note off hadn't arrived in 250 milliseconds, it would return from the sleep. And you can tell whether it returned because of the note off by testing the return value. And there's another version of sleep which is sleeping until the next beat. So that makes it easy to implement arpeggiators and drum machines and things. And it completely hides all the changing of tempo and things that the sequencer might be doing underneath. So have a quick recap. I've managed so far to talk about the note handling and the GUI, so I probably have to go quickly. So I'm going to talk about the audio hooking up side a bit. And here is a bit of a synthesizer. Here it's showing you how you can create audio blocks as Lua objects. So this is actually creating a 2 oscillator synth. So there's a little for loop there, creating the 2 oscillators. Then it's creating a filter there, which is then wired up to the outputs of the 2 oscillators. And the way you do that is just in the constructor, you set the input to this array of the inputs that you want. And that, the fact that there are 2 things in the array is what has ended up instantiating a 2 input filter. You could have had as many as you wanted, and then this block would have made as many channels as you asked for. And then this whole thing, this saw voice thing, is actually a class. This is how you do classes in Lua. There's a bit of funny typing you need at the top, but you get used to that quite quickly. And this class at the bottom is defining well, I can't think what that would be called, but anyway, it makes it look like the same as one of these blocks, which has an the built-in sawtooth oscillator has an output, and this has an output, so then you can reuse it as if it was one of the built-in blocks. And this one doesn't explain much more, but it's just showing you how you can instantiate the saw voice is instantiated 6 times. So this is a guitar-based synthesizer, and 6 strings, so 1 voice per string. And then those have to be wired up to a mixer, and that's done just by shoving all these outputs into an array, and then passing that array to the mixer, which then, because the array is 2 by 6, you end up with a 6 input, 2 channel input mixer. And then the last bit of the puzzle is these envelopes, and this is an ADSR envelope defined in Lua, which is going to control the gain of the mixer input in order to implement the note coming on when you press the key, and then gradually, well, staying at whatever level and then fading out when you take your finger off the key. And the way that the thing that makes that possible is that all of the controls within the audio blocks, you get to set the value. So you can set the value of the gain of the mixer, but you can also set a slope. So the Lua can just set the control to be, say, start going up, and then it can go to sleep for however long it takes for the control to reach its set the value you want, and then it can wake up and then set the slope to be 0 to hold the value. So that's what this little bit of code does for, this is not the whole ADSR, this is just a bit of code that smooths an envelope. So if you had a switch, you don't want the click, you want the the gain to change slowly so you don't hear a click. Yeah, so that's quite an important thing. Here's an example. This is a plugin for MIDI guitarists, and it's mostly a MIDI filter that lets guitarists control which strings they want to go through to the synthesizer that's playing, and which frets they can control, and how pitch bends. There's a lot of fiddly things with MIDI guitar, and also to have a pedal which they can control how notes are held, and so they can solo over the top and things. And this has also got a small synthesizer built in, so for mostly it was just for people to play around with, but it also sounded all right too. And this is something that I'm working on at the moment, which is completely different. Well, not completely different, because this is basically the same as that plugin, but in hardware. And there's no Lua involved, unfortunately, because I didn't put a powerful enough microcontroller on there. But this is the Fishman's Tripleplay MIDI guitar system. So there's a pickup on your guitar. It wirelessly sends MIDI to this dongle here. This whole board here is changes the notes into the analog signals used to control synthesizer. This is a very basic analog synthesizer back here. And I don't know, that's what I'm doing at the moment. Yeah, that's it. Questions? Hello.
Do we have any questions?
Yeah, there's one hand up there.
How'd you communicate the parameters between the two threads so that you have data integrity?
Well, the parameters are single floats. I mean, this is a standard way that plugins work. So they're yeah, it just works. I actually didn't use JUCE for this, unfortunately, but the framework I did use, WDL, just handles that under the hood. Yeah.
Okay, I think we've got time for one more question.
So is Lua safe for doing real-time stuff? Like when you receive a MIDI event, is there a risk that Lua decides to update some method dispatch table and do an allocation and cause a glitch?
Mostly not. I mean, there is. Well, it could decide to do garbage collection. That's the thing that would kill you. But generally, if you call the garbage collector when you know things are okay, then things work. And
can you control the garbage collection cycle?
Yeah. In fact, at the end of that little example, it did have a call the garbage collector. And you can also you can write your own memory allocator. So you can pre-allocate the bunch of memory, and then Lua can work off that pool. So you don't have to go back to the operating system to ask for it.